So, our outline of the periodic table, we have two elements at the top. So that's kind of, we start out with a little box, and then we have two elements down, make it a little bit longer, and then we go across this middle portion. Middle portion has a lot of elements in there we're familiar with, like iron and zinc and nickel and some different things like that you guys have heard about. And then we get into a section, this section is called the non-metals. We talked about the metals, non-metals, right? Yeah. Metalloids. We kind of know what properties they have. So now we're getting a little bit more specific.
Do we need to draw that?
Yeah.
Yeah.
Are we gonna draw the periodic table elements?
No, we won't have to do that. So we have all we're concerned with is group 1, group 17, and group 18. Those are the only ones that we're going to really visit about and talk about. This is the reason why only those three. Okay, if we get into group 16, as you go down that group, this family is not very consistent. This family goes from oxygen down to phosphorus, then it hits a metalloid, arsenic. Then it hits another metalloid, antimony, and then it hits a metal. So this family is quite unique, 16. 16 takes on characteristics of three different groups: nonmetals, metals, and metalloids. Group 15 does the same thing. It hits all different types of characteristics. So some families are really, really good down a group. Now if you remember this group 18, we said that it was, what do we know about group 18 before we even say anything about the name of the family? What do we know about group 18?
Gas.
They're all gases.
They don't want electrons.
They're stable. They don't take on electrons, so they're stable, which means they're unreactive. Okay? And they have a full shell of electrons. We won't say that because you guys don't know much about shells and that type of thing. We already know something about 18. 17, they're the ones that are -1 charge when they gain an electron. Now naturally they're not that way because they would have equal number of protons and electrons. So originally 17, they have not gained anything. Okay? So that makes them unstable, and they'll want to gain an electron so they can be like group 18, because group 18 is the cool bunch.
Are they really?
They are. You want to be like group 18 if you're going to be an element. Okay? And 17, group 17 only have to gain 1 electron to be like the noble gases. And then they're stable. They're okay being like 18 because they'll be stable. They don't like to be unstable. And group 1 doesn't like to be unstable, but they are in their natural form. So they lose 1 electron. If they lose 1 electron, they mainly they go back to 18. It's kind of like, for them to get over to 18, they have to lose, so that this is kind of like 18 over here. If we had a periodic tables back to back, if they lose 1, they're kind of like 18 again.
I just thought it'd be cool to be alkali metals.
It is cool to see what alkali metals can do when they're in their pure form, but you never find them in their pure form. You can't find sodium by itself. It's always with something else because it's so active.
Sodium nitrate.
Right, but it's not in its pure form, which means it has a charge to it. These don't have charges when they're in their pure form. So when you look at them on the periodic table, they are equal electrons and protons. When you see them bonded to something, they're no longer in that original form. They've lost or gained an electron. So they're no longer like they are in a pure form that has equal number of protons and electrons. Okay, that makes sense? Okay. So this first group, now you can either put an arrow facing that inside. I'm just going to put it inside here. I'm going to put alkali metals. Okay? So that is a group. It starts out with kind of hydrogen. Hydrogen kind of has some similarity. Remember we said hydrogen kind of fits over there because it behaves like it. But it doesn't have a characteristic like a metal. So it starts with lithium, goes to beryllium, or not beryllium, but it goes to sodium, then potassium, and down. So that's the alkali metals.
Cesium in French.
Yep. So then group 17 is the halogens. Okay, so that is the halogens. And then this, group 18 is the noble gases. I'd like somebody, and I'm sure I'm going to have tons of volunteers, I want somebody to look up the word halogen to see if it has a different meaning. Okay, a couple of you can do that.
What's that second word on 18?
Noble, N-O-B-L-E, gases, G-A-S-E-S.
Halogen, isn't that like a light bulb?
Yep, they have halogen light bulbs.
They are reactive, non-metallic elements that form strongly acidic compounds with hydrogen.
Right. Does it have any,
Element example.
is there anything else that say anything about like the dictionary? Does the dictionary have anything with halogen? When you look up, is that the dictionary definition or is that just a Wikipedia
That's
definition?
just a dictionary definition.
Does it have any other definitions?
More definitions. Denoting lamps and radiant heat sources using a filament. I think that's just talking about a light.
Right. Halogen light.
Yeah, that's like car light headlights.
Yep. I think it has.
Halogen atom or something.
Okay. So I didn't know if it had a particular meaning to it or not. I thought at one time there was a particular meaning in it. It might mean halogens will form acids when it combines like with
Salts
hydrogen.
can be made from halogens.
Yeah, that's what it is. Okay. So 17 is a salt maker.
Oh, filament surrounded by a vapor of iodine.
Yeah. So
That's
iodine.
That's how they light up, huh?
Right. So if you have something with the iodine in it, it's going to not have a real bright, but it's also going to be kind of a
So is there iodine?
brownish color.
Can you mix iodine and neon?
Well, they won't interact with one another. They just stay separate. They're mixtures. Okay. So questions on those groups. So I'm going to give you some information about each group I'd like you to write down to know. Okay? So, alkali metal. You guys can write this down below if you want. Oh, let's do this. Right here, up above, I'm going to write, these arrows going left and right represent periods on the periodic table. So period 1 has 2 elements in it. It's the top column. Period 2 starts with lithium and goes all the way over to neon. That's period 2. There's 8 elements in period 2. Period 3, there's 8 elements in. Period 4, there's 18 elements in. And then if you get down to period 6 and 7, there's 32 elements in those two. So it goes 2, 8, 18, 32.
2, 18, 32.
Okay? But period 1 would be the first row. Period 2, the second row. Now groups are also called families, and they go up and down. So I'm going to go here, and this represents groups and sometimes families if they have a lot of characteristics the same. Okay? So groups and families go up and down. Periods go across. Okay, so in here, I'm going to go ahead to put the first group. It's called alkali metals. You guys can write it down below. There, if you got room.
We're already in the middle of our periodic.
You can. You just have to, I'm just going to write smaller. So alkali metals are unstable, which you guys know is very reactive. Okay?
So like.
By the way, as you go As you go down the group, they get more and more reactive. So sodium's reactive with water, but potassium starts on fire in water. Rubidium blows up in water.
I want to see that.
Okay? Because as you go down, the reactivity, and they become more and more unstable down that family. Yep.
Is there anything that they're unreactive with?
No. Well, the noble gases. You could put them in a noble gas and they wouldn't do anything.
Is that how they transport them?
Could. There's other ways. I've got this. I got some sodium up here, and it's in mineral oil.
I want to see sodium. I want you to put a little chunk in some water.
We are. Okay. All right. Next thing. Next thing, not found free in nature, and I'll explain what I mean by that. What that means is you don't find it by itself. It's always going to be with something else.
How do you get it by yourself? Oh, boiling it.
No. If it's with something else, you're going to have to do a chemical reaction to isolate it. Okay?
That's what I meant.
So, it's not found free in nature. It's unstable. It's a soft, low-density metal.
Gold. Gold is soft.
It's soft, but it's a high-density metal. So, it's a soft, low-density metal, and it reacts with water. So, I'm going to show you that later on. So, I'm going to show you sodium later on. Okay? Questions you have? That's all we're going to put in there. We could also put down there, it'll tend to want to lose electrons, but that'll come later. All right? Okay, so the next one. Halogens.
My favorite pen.
Halogens are unstable. So they're just like the alkali metals. They're unstable. Chlorine, fluorine, bromine. They're all poisonous. Okay? They all are colored gases when they're a gas.
So those lights that look like a pig's tail,
Yes.
those are.
That's
That's
neon.
why they're poisonous.
No, that's not a halogen. That's neon. So that's not the same. Okay, so they're all colored gases. Shh. Not meaning you put electricity through them and they light up. It's just in their natural form they are a colored gas. There's some examples. Chlorine is green. There's chlorine. Okay, there's bromine. It's brown. And iodine is kind of a purple color. Okay? Each one of these are poisonous. Okay? So those are examples of those gases. Okay? What's that?
Like somebody accidentally knocks down.
No, I messed with bromine one time, and I was trying to. It was in a bottle with plastic, and I had gloves on. I was smart enough to have gloves on, but then I was cleaning it up and trying to get it to where it was, because some of it kind of leaked, and my face started itching. It became itching more and more, and I was just like, uh-oh, this isn't right. And my face just started itching all of a sudden all over. Okay? So if you're in lab and you start itching in a spot that is just really an irritant, you probably got something on you and you need to wash it off. Okay? If you touch your face and you got something on you and your face starts itching, it's like you take a wet paper towel and you start wiping that area to get it off. Okay? Because that's what happened. All right? So they're unstable, all poisonous, and all are colored gases, and they're never found free in nature. You can't find them by themselves. Now you can chemically produce them, but in nature, you go looking for chlorine gas, you're not going to find it. Okay? And then the last one is your noble gases. Now, noble, you think of nobility, you think of people that are kind of higher on the social ladder, probably the highest there are on the social ladder. So you think of kings and queens over in England and some of the different monarchies that are present. They don't mix with commoners. They don't like to marry, have their family members marry somebody that's outside of that monarchy. And so that's why it's easy for me to understand what noble gases are, because they kind of stick to themselves and they don't mix with any of the other elements. So these are always found free in nature.
Francium's liquid?
Okay. Very stable. Okay, so which means it's very unreactive. It's not reactive, and they're all gases.
So these ones aren't gonna just all of a sudden blow up on you like some of your girlfriends.
Yeah, they're very stable. They're not going to mix with anything. They're not found in compounds. Okay. Okay, and we'll put that down as not found in compounds. Okay, so first thing I'll show you is the sodium.
It's just bubbles.
You're probably shouldn't have done that. Rabbits. Grill all the time. Bro, you need to get some. Your grill all the time. Cut out 2 spots. Last 2 days, I go by. Were you grilling who dogs? Well, I said Tony Stark. Yo, they make gloves.
Okay, I won't pass it around.
Yeah, that's right.
Pop it in your mouth, see if it reacts.
Okay, give me a.
Okay, let me do it. Yeah, I'll do anything. As they go to the hospital and the mouth is all destroyed.
That's a really soft metal. What is that?
Okay. The outside is grayish, kind of it's calcified over. It's more silver than that, but that is sodium metal. Okay, it's different than sodium and sodium chloride. This can really hurt you. Okay, if I leave it out and let it dry out, it's going to react spontaneously with oxygen in the air and just start on fire. Okay?
Almost wanted to do that.
Yeah.
Start on fire.
Well, I don't know. I know it's coated with mineral oil. Okay? I'm going to go ahead and slice a piece so you can see the center of it more.
That stuff costs.
Time is ticking, Mr. Don.
You get out 40, don't we? You get out 42, don't we?
I'm saying for that stuff to dry out.
Oh, yeah. It will dry out that fast. Alright, so you can see a little bit of a silver, because metals have kind of a silver color. So it's kind of like metal. You can see it does have a luster to it. It's like fish.
That is not weird.
Yeah, it does kind of look like scaling a fish and that.
Who are you going to scale the fish?